Good day, everyone. Welcome to Chemistry with Professor John. All right, I'm excited about this. This is General Chemistry 1, that's Chem 201, Chapter 1 to Chapter 3, Study Guide. Okay, well, let's start with Chapter 1, which is, uh, and you know where to get the book, from OpenStack. Here's the information again. If you're not sure. Okay. Chapter 1 with the essential idea, that's matter, measurement, and problem solving. Okay, so here's the key concept that we need to know to master, okay, and the skill. Okay, as you know, chemistry is the study of matters and changes it undergoes. Now, the scientific methods, whatever we do, we need a method. We do science, we need a method. And these are the steps, these are the components of the scientific methods that we follow. The first thing we do is the observations. We make observation, we record the data, and of specific events or experiments, and we come up with hypotheses. We define the problem, okay, to be solved, and that's why we come up with hypotheses. We propose a possible solutions for the specific problems, okay, and then we try to prove it or disprove it by experiments. We run experiments. Now, if we prove it many times, well established hypothesis, it becomes a well established hypothesis. We call that a theory. And it's very helpful. If the theory is good, we can use that to explain uh, future phenomena. Now, scientific law is an ultimate statement of natural phenomena that happens over and over again with no exceptions under given conditions, of course, right? Okay, so here's a few examples of the scientific methods. When someone write a statement, say flowers need sunlight, that someone is making an observation. As you can see, right? When someone carrying out a lot of observations, probably a lot of experiments, and come up with the statement, the conclusion that say matter is composed of atoms. That is a scientific theory. And then if someone make a lot of observation and say matter cannot be destroyed nor created, that's a scientific law. It's not like government law or traffic law. This is absolutely right. Okay? If someone give us instruction how to mix certain things together and create a reactions that look like an experiment, and someone make a statement after try a few experiments, say strong metal tend to react violently with water. That look like a observation, but it's actually a hypothesis because there's a conclusion there. There's a prediction there. What's going to happen if you do this? There's an explanation there. If you mix strong metal with water, they tend to react violently. You still have to test that. So that's why it's hypothesis. Okay? Here's a couple more good one. The pressure of sample of a gas is directly proportional to the temperature of the gas, meaning if temperature goes up, the pressure also goes up. That's directly proportional. So that is always true. That's a scientific law. Matter composed of or consists of tiny particles that combine in specific ratio to form substances with specific property. The word matter composed of tiny particle, meaning atoms, right? So let's look like a theory. And finally, at high temperature, solid will dissolve better in water. It's a hypothesis. Not always true though, okay? That's why it's hypothesis. Okay, we coming down to numbers. Now we got the methods done. Now talking about numbers. When we do experiment, we always need numbers for measurements. And numbers, some numbers are important, some are not. The one that's important, we call them significant figures, okay? So significant figures are important number. For what? For quantity and precision, okay? Now, how do we decide, okay? Which one is significant? Well, all non-zero, rule number 1, are significant, and so on and so forth, right? So let's do the problems, okay? You can use common sense. For example, 2546 has how many significant figures? Obviously 4, because we need all of them. 25 has 2, but 25.00, we're going to need all 4 of them. That's a decimal point, we're going to count all. Those 2 zeros are for precision. Okay, 2500, no decimal place. Zeros doesn't count. Lot 2, 0, or we can say the 0 don't count because of no decimal place. 5,000, same thing, just 1. However, if you do 1.000, that's 4 sigfit. Precision. And this one has 5 sigfit. When you multiply, you just multiply like normal. You got 3 sigfit, you got 4. Your final answer is what? 3.75? That's it. Cut it off. Take the lower one. So you always go with the lower one. That's what it means. When you subtract or add, you do like the old-fashioned way. You got 50, 0.41, right? You cut it off right here. So your final answer is 14.5. No more, no less. All right, you got the idea, okay? And when you're in the class, you can go ahead and check out all the answer in my binder. All right. Unit conversions, system, SI units. We got a few things to measure, and those are the popular units like mass, the popular units in kilogram, temperature in Kelvin, time in seconds, so on and so forth. Now, scientific notations mean exponent. Okay, it's so useful. If you do exponents, you don't have to write too many zero. Or if you got a lot of zero, well, this one doesn't help much, but this one help because that's a lot of zero. You just write 10 to the minus 6. You're done. That's significant. That's scientific notations. And that's actually tied up with the next concept is the prefixes. Okay. Going from really small to really large. Okay. For example, 1 and what is good for? Conversions. If you do 1 nanometer, nano mean 10 to the minus 9. You can also do the positive, but you got to swap them, right? Because 1 meter, you got to put the meter to the left and then nano to the right. You can do that if you feel comfortable with that conversions. Temperature conversion is pretty straightforward. That's TC is TF minus 32 divided by 1.8. And then if you have TC, you add 273, you get yourself TK. All right, so let's say we got temperature in the freezer is minus 10. What is it in Celsius and Kelvin? So TC is going to be TF minus 10 minus 32 divided by 1.8. So that's minus 42 divided by 1.8 minus Celsius. And it should be 23.33, right? Negative. If you want to do Kelvin, one more. It'll be around 250K Kelvin. Okay, it's good enough. Okay, and density is the next calculations. Density is mass over V. So you can create mass is density times V, and V is mass over density. Remember, mass is the easiest one because M means multiply together. Everything else is going to be divide. And M's always the numerators. You notice that. Always the numerators. Okay, how do we solve for this? What is the mass? So mass equal to D times V. D is 13.5939 gram per cubic centimeter times V, which is given 6.0. Cancel out, that will give us gram, right? And it should be 81.6. What is the mass of 25 mil? Remember, ml is the same as cubic centimeters. So mass is d times v, or v times d, doesn't matter. Density is 0.703 gram per cubic centimeter times 25. Okay, cubic centimeter cancel out. You got multiply together. You should have, this will be 2, sorry, 17.6 gram. Okay, and again, volume, another formula is mass divided by density. Mass is 1.11.3 gram divided by density 2.25 gram per cubic centimeter. You get 5.02 cubic centimeters. Okay, so those are the important calculations. You can see other topics including precisions. We've been talking about that. You know, consistency, accuracy, how close you are to the true value, classification of matters like gas, solid, liquid, gas, things like that. Okay, energy. We need to know there's 2 different types of energy. One is kinetic energy, the other one is potential energy. That's store energy. Kinetic means motions. Potential means store, I say right there. Okay. Temperature conversions, we talk about that. Density, dimensional analysis mean multi-step conversions. You can go from kilometers to micrometers, okay, something big all the way to something small. Unit raised to power, pay attention, this one is important. 1 inch is 2.54 centimeters. So if you square, you gotta square everything. 2.54 square as well. Cubit, 2.54 cubit as well. And a couple miscellaneous topic, you know, like physical static of matters and stuff. Clarifications, you have 2 different substances, element and compound, and mixture, and then you got all kinds of components in a mixture, right? We got more practice problem here, and let's get you guys have give it a try, and then I have answer for you to check on this one. Great. Before you move on to chapter 2. Okay, sounds good. So we'll see you in the next video when we discuss more about these 3 chapters. Okay, thank you guys.